In this part two, I'm going to talk a little bit more in detail about the force plate data when you do a counter movement jump. All the check mark points are something I already talked about, and some considerations when you actually try to interpret a vertical jump data. So we're going to talk a little more in detail about this. So something I ignored in part one is this red line. So this red line is the velocity. And we're going to talk a lot more about the velocity curve interpretations as well as different sections, different phases of vertical jump. So at the very beginning of the vertical jump, the moment you initiated the movement, as you can see in the blue line, the force plate data actually goes to the negative direction. So this is the moment you begin the downward movement when you drop your body weight. I actually want you to do this. I want you to stand straight and get down as quickly as possible. Basically, when you do this, you drop your torso, right? You drop your torso towards the floor and bend in your knees. When you do that, I want you to pay attention to how much force you're exerting against the floor. When you focus on bending your body, you realize you actually exert less force. So because of that, the force goes even below your body weight. So that's why this phase is called the unweighting phase. So the unweighting phase begins when the vertical ground reaction force goes below your body weight until it goes back to your body weight. Another way to understand the end of the unweighting phase is when the velocity reaches its peak negative velocity, fastest point of going down phase. Okay, so that's the end of the unweighting phase. The next phase is called the braking phase. So what's happening during the braking phase is even though your force is going up, what's really important here is you are actually still going down, or this is pretty much the end of going down phase. And how do I know it is still going downwards? It's because the velocity sign is still negative. That means your body is still directing to the negative direction. So that's why during this phase, even though the force is increasing, from the velocity information, you can tell that you're still going downward. But you can see that velocity, the magnitude of velocity is decreasing, meaning you are changing velocity over time. Therefore, you are decelerating. That's why it is called the braking phase. This is also the moment your body weight is loaded on your legs. So this is the moment you feel the tension on your legs. So the beginning of the braking phase is the end of the unweighting phase. It also ends when the velocity actually crosses zero. So when the velocity sign changes from negative to positive, what happens? The direction changes, right? So the moment here, from this moment, what happens is you begin to extend your body and going upwards. That's why this is the new phase. It's called propulsion phase. When you focus on the type of contractions, your muscle is concentrically contracting the muscle fibers, right? So therefore, it is also known as the concentric phase over here. So one of the most common mistakes when you examine the vertical jump force data is that this is the positive deflection of the force, so you are beginning the upward movement over here. No, the upward movement or actually begins here, right over here. This is because when you look at this, this is still negative sign, then the velocity is move into the positive direction. Therefore, this red area is the propulsion or the concentric phase. So, depending on the definition, some people call from the beginning of the movement to the end of the braking phase as the eccentric phase. Some people call only the braking phase as the eccentric phase. Okay, so being able to understand the breakdown, the velocity curve, the force curve, and the actual movement is basically the understanding of the force plate data. And there are a few more things I want to discuss, which is over here and the slope of the force curve and this vertical, beautiful, straight vertical slope. First, at the end of the braking phase, some people you see this like a small spike in the force plate. So that can be a potential end of the braking phase, but some other people actually do not have those small spike. It really depends on timing and the magnitude of the arm swings. So it's better to differentiate the eccentric and the concentric phase by the direction of the velocity. Okay, so that's the first thing. The second thing, researchers can also look at how sharp is the force development. So if the force development is sharper, what indicates is that you can develop force more quickly, right? If you can accelerate your body faster, that means the formula of force is mass times acceleration, right? So if you can accelerate faster, you can generate more force. Therefore, the slope of the force development curve can be an indication of how explosive you are. Some people look at the slope from here to here. Some people they look at the slope from here to here. So that really depends on the definition. Regardless, this slope is called the rate of force development, also known as loading rate. And then lastly, it's kind of review from the projectile, the linear kinematics of the projectile. Whenever you see a human velocity curve, it always have like complex nonlinear curves because we can never increasing or decreasing or maintaining velocity perfectly, right? So you can never see a perfect line, but this moment, from the moment your body goes in the air until you land, you will see a perfect linear curve. And this is because the only external force that affect the position of your body is the gravity, right? So gravity is constant, which is negative 9.81 meter per squared second, right? When you see a negative flat acceleration line, what do we learn? You will see a linear velocity. So this is one of the very rare perfect linear velocity you will see in my human movements. All right, so now that we have actually covered all the phases of vertical jump and other components of the vertical jump,